Greetings everyone, my name is Vijay Nair, the founder and CEO of Funnel Labs, and today we're going to be doing an engineering quick start for how to use the funnel system. In order to talk better about how the funnel system works into your company, we're going to work with a demonstration, a demo company. So we're going to call this company MusterTaxi.com. It's like a portmanteau of Mr. Taxi and the word Muster. Muster is a German word which means like example. So this is basically like saying exampletaxi.com. So in our simple business, we have two apps. There's a customer app, which allows people to search for taxis, and they may search on them for a wide variety of reasons. They may search for the number of seats the taxi has, or what kind of car the taxi is, or whether it's located near where the customer is. At the same time, there's a driver app. The driver app is actually looking for nearby customers. It's maybe awaiting a booking to be received from the back end of our system. And our company is actually struggling a bit. The solutions that it built in the very beginning that worked well aren't working so well because the number of customer and cab data is actually growing and growing and growing. What we wanted in our business is we want the system to be responsive and constantly updating, and so we need current positions of our taxi drivers. In order to get those, our taxi drivers are sending a message called a taxi update, and this message is being sent every 10 seconds. So what this means, though, is that with only 10,000 taxis, which is not that many, our load is already at 1,000 requests per second. The systems are struggling to keep up with this load, and the maintenance cost of keeping these systems up and alive is growing and growing and growing. So this is the context in which we're going to talk about how the funnel system can be of use. So let's take a moment to talk briefly about the evolution of company technology. Yes, systems become complicated, but they don't start off that way. Usually systems start off really simple, maybe a simple database, but then complexity grows, not because engineers just want to make things complex for the sake of being complex, but they get asked to build new features. Maybe these new features depend on data that the system originally did not have. Thus, the engineers have to build more complex systems to produce that data. Same thing, there's an increasing demand on the system, like sheer amount of load, and maybe the simple database that existed at the start of the system is collapsing under that load. Then, of course, there's performance limitations that are discovered of technologies or just based on physical limits, like how many I/O operations a database can perform per second. Of course, on the business side, companies have to keep an eye on a wide variety of additional factors. So they have to keep track of release timetables. When is something going to be out there? Now, your competition isn't necessarily going to wait for you. And then, of course, whenever you choose to build something, especially something that doesn't have feature-related work, that takes time. And from the customer's perspective, nothing is changing. So that time can be often seen as being in competition with development on features. And it costs money, salaries, and costs quite a bit of money in a company. It's the predominant cost in most tech companies. And the infrastructure itself is not cheap either. Yes, even if your system is deployed in a cloud, the clouds aren't free. Even the cost of simple things like load balancers can become significant once your traffic numbers become very high. In this image, I use the evolution of the mollusk eye to show like an increasing amount of complexity as the need arises. The back-end systems of a company may change. They may start with like an initial prototype, and that initial prototype could have something as simple as like a relational database. Customers need to know about nearby taxi drivers, and then drivers may be searched for to basically meet that demand. At some point, the read load starts to get too high. Your system's having a struggle to keep up. So a common solution is to add read replicas to your relational database. You still need to be able to query for drivers by location, by car type, etc. But to keep up with the load, you add a bunch of replicas. But then the load keeps getting higher and higher, and maybe your system is even growing in more complexity. So you end up sharding your data. Perhaps you end up grouping your data together through batching mechanisms. But keep in mind, even after you shard your data, each shard is going to need its own read replicas. And then you end up with a system that gets more and more complicated as the load grows. You end up with a system where, in addition to the sharded data and the read replicas and the batching streams, you have to have caching layers. Maybe you're using something like Elasticache in AWS. The cost of the infrastructure starts rising and rising quickly, and soon enters into the arena of tens, if not hundreds of thousands of dollars per month just in infrastructure cost alone, let alone the time it took to actually build all this complexity and design these software systems. So why do systems get this complex so quick? It's not a choice just at random by engineers. It's to deal with the performance limitations and the performance limitations of the software that is being used. Typically, the two most common types of software that are used are relational databases and memory caches. These systems are good, but they have limitations. Many of these systems were essentially built before applications like micromobility or ride-hailing even existed, and thus the use cases that they are built with in mind don't necessarily match the problems that businesses are facing today. So a relational database powered by using an SQL query language has exceptionally strong and flexible abilities to search for data. But especially when you start writing data and indexing that data, it really starts to suffer in performance. But these databases are atomic, and if the power could be shut off and your data will be preserved. It does a very good job of actually preserving data. Then you have cache systems. Cache systems like Redis or Memcache, they differ in some ways. But in these cases, they tend to be key value lookups. So you look up for data given a given entry, like its ID number or something, but that's about it. If you build a query system, it's quite complicated. You have to make your own indexing, and getting a data cache system to be able to support queries is a lot of work, and the performance goes down because the number of key value lookups you have to do to execute those queries grows and grows and grows. But what these systems excel at is performance. One of the reasons why they are so good at performance is because they're not spending as much time organizing data on disk like a database does. But that doesn't mean that they're a slouch when it comes to data retention either. These systems can basically write snapshots to disk, and as long as your data is reasonably up to date, you might lose like a half second of data depending on the snapshotting mechanism you're using or whether you're using log data retention. Cache systems actually these days do a pretty good job at keeping track of data. But we're in a bit of a bind. For a business like ride hailing, what we want a system that has really high performance like a cache. We want to have that. But we also want to be able to execute flexible queries like a relational database. We want to be able to search by the number of seats in the car, how close it is. And dealing with the limitations of each of these respective systems is one of the reasons why these systems become so complex. So how does Funnel help? How does Funnel fit into things? One, it just saves a lot of the work of building a system because the Funnel system is built directly as a distributed architecture in the cloud. So all these problems you have to worry about, like handling high amounts of network volume and load balancing it, that's built into the Funnel system. So it's not just a standalone piece of software like Postgres or Redis. Second is that it's built in a way that's extremely efficient. It's actually written in a machine compiled language. It's not written in Java, it's not written in Python. It is basically a bare metal kind of system, and the performance it gets is pretty exceptional for the kind of code that it does. Funnel also supports flexible queries, kind of like SQL, and it also has high performance. Furthermore, it's easy to use. Most of the configuration is in the form of simple JSON files, which are quite easy to maintain and update, and all the updates can be done while the system is running. So it seems kind of odd. You end up getting the high performance, high query strength, and high performance, but you have to get nothing in this world that comes for free. So what do you give up in return? You're essentially giving up on highly persistence of this data. And this is kind of rational for the kind of problems that your business may be facing. So if you're constantly receiving the location of a driver and you're serving customers from you're serving queries from customers, the customer doesn't care where the driver was 5 minutes ago. They care about where he is now. And the way the funnel system works is the whole system is built around indexing and caching data, the current data. And this is where a lot of its efficiency comes from. It makes current data a first-class citizen, and it's trading away some of the flexibility and power on historic data. And this is one of the secrets in the architecture and software design of the funnel system that leads it able to straddle both of these worlds. So let's talk a little bit more about how it actually works. And the first step of that is authentication. So how do you actually create an account? So before you can authenticate or work with a funnel system, you have to create an account. Process begins by just reaching out. So send an email to contact@funnellabs.io to begin a conversation about getting your business signed up and able to use the funnel system. Once this process is over, you'll have a username with a password. This password should be kept secret. These credentials are for use in your backend systems. So we have our user called Mr. Taxi, BE for backend, and we have our password over here. Then you also have a collection of namespaces. When you define your data formats, all your data formats must exist in a namespace, and this namespace it's used to organize data, but it's also used in the funnel system itself for distributing load and making sure the system runs as efficiently as possible. So before you can do any kind of request to the funnel system, you have to basically get an access token. Now, anytime you need to refer to the details, the full documentation can be found online in the funnel-labs.io website. The documentation has full descriptions on how to do everything. So calls to the funnel system are secured using JSON Web Tokens, and you can simply follow the OpenID Connect specifications to do a request. So for this example, we're going to be using the command line tool called curl, but you are likely going to be writing code in Python or Java or Kotlin, and you're going to be making requests through your system. So we're just using a shell script to demonstrate the raw data in a universal way that can be understood no matter what language you're using. In this case, there's a base URL that's common to all these requests. It's https://auth.funnellabs.io/auth. So in this case, we start getting a token by using the path auth realms funnel protocol OpenID connect token. It's a long URL, but that is actually the standard URL format for the OpenID connect protocol. So we have to set a few query parameters in our request because it's actually a form submission. So the client to be used is called service. We're asking for a password access. In this case, you just enter your username, you enter your password, and what you get back is an access token. This string has been shortened. It's actually a very long string, but to make it fit on the slide, we've shrunken it. And you have a refresh token. Access tokens are what you use to authenticate requests to the backend system. And these things only live a certain amount of time. In this case, it's only living 300 seconds. So when these things start becoming old, then you can basically refresh them by using a refresh token. The way refresh tokens work is very simple. Instead of saying, I want a grant type by password, you say refresh token, and then you can use it. For the sake of these further examples, we're going to save our access token into a shell variable. So all we do is we make the same request that we have above right here, and then we just pull out the piece that is the access token. So this value here that's in quotes, this is our access token, and this is what we're saving in the shell variable called access token. So let's suppose my access token, I've obtained it, but it's getting old. Then what you can do is, as long as a user is active on a system, you can keep refreshing it. And the way you refresh is very simple. You don't have to expose the username and password again. You can simply say, instead of grant type password, say grant type refresh token, and then pass it in, and then you can get a new one. This is great in situations where a third party, perhaps the customer app, was originally granted access through your system. Your system maintains the username and password, but it does not give that to a user. But once a user receives his login credentials, he can refresh on his own using the refresh token, and you never have to give him the password. So how do you authenticate requests? This is following standard protocol. All you basically do is whenever you make a request, in this case, we're just sending some data to upload a taxi update message, you add an HTTP header, you add the authorization header, and you give it a token of type bearer, and then we pass in our value. Earlier we had saved the access token value into the shell variable, and so you just pass it in under the authorization header, and then everything works as you would expect. So next step is, if you're going to work with the final system, you actually have to define what your data format is. So we're going to go through a few examples of what that looks like. So to understand what data format you're going to do, you have to have your company problem in mind. So we're at mustertaxi.com, and we're going to actually look at the kinds of things that they're doing and define a data format that reflects this. Your company likely already has a data format, and it's quite easy to translate into a format that Funnel can use. So let's take a look at our requirements. Customers can search for a taxi based on how close it is, the car type, and the number of seats it has. Drivers emit a taxi update message every 10 seconds that contains a driver ID, the location of the driver, their car type, and the number of seats that they have. So they emit the same data that a customer can actually search on. Simple enough. So let's start defining our data. The way you define your data is using the Apache Avro syntax, which is a schema, but the schema itself is in JSON format. So let's start breaking apart our requirements for the taxi update, which is sent by our drivers. So the first thing is you have to choose a namespace. It's like a container for your data to live in. This is the one assigned to our account, com.mustertaxi. I'm just using Java naming conventions, so the com comes in front. It's a common thing to do. You have to name your data type. So in this case, we're calling it taxi update. And the type we have is a record. A record is akin to a JavaScript object. It's just a collection of fields, and each field has a name and its own type. And each field can have a different type if you so choose. It's just a generic piece of information about your company. So we're going to start defining some of these fields. Let's start with the driver's ID. In this case, we know the driver's ID is numeric, so we define our very first field. The very first field, we're going to give it the name ID, and we're going to choose the type int, which means integer. It's a 32-bit integer. We could have chosen long for a 64-bit integer, or we could have chosen just a generic string that allows it to be anything we want. But for the sake of this example, we just chose a simple integer to represent the driver ID. Next, we want to define a driver location. In this case, we want to define the location as a latitude-longitude coordinate. So the type we use for this is actually an included type. In Apache Avro, you have two ways of defining a type. You can list them by name, so I can refer to the type called int, or you can define a type in place, and that's what I'm doing right here. I'm defining a type, which is a record type, because I want to have multiple values. In this case, the name of this is called location, and I can reference this type later on. And I have two fields, one field named latitude, one field named longitude. In this case, I'm using 64-bit double precision to represent latitude and longitude, which is good to, I believe, approximately 13 decimal places. Then we have a few more fields. We have the car type, and the car type in this particular case is over here. We have two types of cars that we have. We have the economy car and we have the business car. So in this case, we define them as symbols. So instead of doing a type like int, our type is actually an enumeration. We're naming it car type, and with these two values, economy and business. Finally, we define the number of seats, which is a simple integer. So I've defined my data format. That's good. But we're not quite done yet. In order for the funnel system to enable your data to be queried, you have to describe which data fields do you want to be searchable and how do you want them to be searchable. The idea is that every single time you define an index, it costs you in terms of space and performance, but it gives you the ability to query your data. And there's a few different types of queries depending on the capabilities you're looking for. So in this case, the first thing we need to do is define a primary index. A primary index is used to essentially determine which two data records are referring to the same underlying entity. So in this case, the underlying entity is a driver and a taxi. And so because each one has a unique ID, the ID is what we use to differentiate the records. So if driver 1000 sends an update message, and then I get a second update message from driver 1000, I know that this is an update to the same driver. So indicating a primary index is very important in order to update your data. The second thing is we have this location, which was the latitude longitude coordinate. Because this is a latitude and longitude coordinate and we want to be able to search on Earth, the surface of the Earth, using distances like meters or kilometers, we define the special index type a spatial index. A spatial index gives us the ability to search on this data by distance. Next, we have a car type. The car type was either business or economy, and we only want to be searching on equal values because comparing car types doesn't really make much sense. Like, would business type be greater than or less than economy type? It's not so clear. So in this particular case, we do an equality index. Equality indexes have very, very good performance, but you can only search if one thing equals another, and that's it. Finally, we have this number of seats. Here we actually may want to compare values. I want any car as long as it has more than 4 seats, for example. A 6-seater car would be fine. So to do that, we create a comparing index. And the only thing it costs you is it costs you a little bit of performance, but you have more flexible queries. So, and that's it. It's just you define these fields and the system automatically will accept them and your system will become ready to use. So let's get a little bit more into that. So now that we've defined our schema and we have it ready, and your company can have many schemas, how do you actually get them into the funnel system? Let's talk a little bit about that. So the way you do it is, assuming you have your schema in a file. In our case, we have a file in the directory mooster_taxi/taxiupdate.avsc. AVSC is the standard file extension for an Avro schema, and we're just keep following that naming convention. All you have to do is make a request to the funnel system to api.funnellabs.io, and then you want to go to admin/schemas and make a post request. In this case, we're uploading the contents of a file. This little @ symbol just says, as the request body, include the contents of this file. We're declaring the content type to be JSON, and of course authenticating our request. That's it. You should get a response that just says OK, and the schema has been applied and you're now ready to basically start working with your data. So you can also read your schema back out. If you need to know like what is the schema of data the system is currently using, you basically make a request, but instead of doing post, you do get. And when you have to say what you want to get. So in this case, it's the same beginning of the URL /admin/schemas. And then there's 2 more parts of the path. The first part is the namespace that you entered. In this case, it's com.mooster_taxi, and this is read out of your Avro schema file. So whatever was in the Avro schema file, that's what will be used here. And then the data type name, and this is also read from the Avro schema file. So in this case, we called it taxi update. So in this case, I can actually read and get back what does the system think my schema is. Uploading data. Now that we have a way of actually saying our data format, how do we actually provide data to the system? So one of the advantages of Funnel is that it's cloud native, it scales, and you can actually, it can handle high load. But if the part of your system that is struggling under high load then has to forward the data to Funnel, it can actually add load to your system without actually helping any. So there's several ways in which you can upload data, and let's take a brief moment to talk about them. One way of actually reducing load on your system is just to have the user authenticate and get a JSON web token for the Funnel system, and then pass that information to your client in the mobile app, for example. Maybe it's the driver app or the customer app, and then have them talk directly over the internet securely to Funnel and avoid putting that load on your system. So this is kind of a picture example of what that might look like. So in this case, the flow would start with, you have a user, he doesn't have access to data, so he basically sends a request to log into your system. Your system actually has its own authentication mechanism, and you contact Funnel and say, hey, I have my company password and my company username. I need a JSON web token in order to communicate with Funnel. That token can actually be sent back to the customer without sending them the username and password. So in this case, they can now directly start sending additional data. They can authenticate requests. So you have two ways of actually handling your system. Maybe you have a certain amount of data that you still want to send directly to your system. Maybe it's for icons or your web page or whatever happens to be. You also have the option of allowing these users to directly send their data updates to Funnel, whether this be a position update for a taxi driver or an initial query from your customers who are looking for nearby taxis. In this case, the Funnel system essentially uses its own load balancers and its own network architecture to basically evenly balance the load and handle very high numbers of requests. And in that way, you don't have to worry so much. You can actually reduce a lot of burden from your own system, especially if it's struggling under like database load and other problems. All right, now that we talked about the different places you could upload data from, let's talk about the actual mechanism of doing it. So in this case, the data follows the Avro schema in JSON. So we just have a record that basically follows the schema we had. Let's just say we have driver ID 3. Here's his latitude, longitude coordinate, and the car type is business. And he has 2 seats. So you just pass this in like normal with a content type of JSON. You authorize it as we described before, and the URL is the important part next. So you go to api.funnellabs.io. You declare your user here. The reason why the user is actually part of the URL is because this is what we're actually using internally for load balancing in Funnel, or if you elect to have a dedicated cluster for your system, this URL portion allows you to route your traffic accordingly. So when we're either querying for data or uploading data, we use the URL path data, and in this case we include the namespace and the data type. So we're just posting data to this URL, and you receive the response, okay, and it's up there. You can actually start querying for it now. So let's talk about the querying of data. Now, queries can be used in many different ways. So depending on your system, queries may be directly used by our users or not directly used by your users. It could be by your backend systems. So for example, you might want to show up-to-date data of where the nearby taxis are for a customer, and that query result could be that query could be made and seen directly by the customer app, but you might actually want to use it in a different way. Your backend systems may say, hey, here's a customer and here's his current position. I need to find a taxi and I need to contact them in order to arrange a booking to pick up this person. So what you want is a candidate list of like maybe 4 or 5 different taxis who might be interested in taking this ride, and you want to kind of prioritize and order them, reach out to them, have them acknowledge their request. But all this algorithm starts off by needing that list of taxis to then later prioritize and organize. So in this case, the funnel system could be used to initiate a search for taxis that are within the vicinity, within the range of that customer, and then the rest of the business logic goes from there. Now, this is not particularly like novel logic, but the main reason for doing it through the funnel system is that it's very flexible. It's easy to add new types of queries and update your data, and the performance. That's kind of what you need for scaling your system. So how do you actually do it? The way you do it is pretty basic. In this case, you authenticate like normal, and we actually use the same URL like we used last time. It's api.funnellabs.io, users, Mr. Taxi, and then you say data, and you have the namespace, com.mrtaxi, the data type, taxi update, and then you say query as the query parameter. So I say query is equal to, and then this is actually the query that's entered to the system. Now, don't forget, you need to do URL escaping of these. So this is why there's things like %20 in there. %20 basically means a space. It looks like junk, but this is what the actual query is conveniently written up here. So I'm saying car type is business and the location is within 20 kilometers of this latitude longitude coordinate. So that's an example of a query being sent to the system, and what you get back is a JSON array of results. In this case, we found a single record. It's that record we actually uploaded in the previous example, and that's it. All right, now the closing remarks. The funnel system is providing a way to help scale your company's system by executing with very high performance and very flexible in the kinds of queries it could submit. And it basically can help reduce the cost of what your business is doing so that it can run more efficiently. And more importantly, it can save time. The less time you basically spend wrangling with performance and trying to make the system scale to handle the huge amount of load from customers and sources of data that are updating in high amounts, the more time you have to focus on things like feature development. So in conclusion, I just want to say thank you for taking the time to listen. And if you're interested in using the Funnel product, send an email to contact@funnellabs.io. Take care.